Hi everyone, my name's Reid, and this is a project I conducted with my colleagues Hamad Alizari and Albert Katz. And the title of this talk is Metaphors Where the Neighborhood in Which One Resides Interacts with Interpretive Diversity. So, as you might already know, a metaphor involves framing one concept in terms of another dissimilar concept. So the concept being framed is referred to as the topic, in this case, world. And the concept used to frame the topic is referred to as the vehicle, so in this case, stage. So we're trying to make some point about the topic using the concept of the vehicle. And metaphors can vary in terms of how many different interpretations they elicit. So with a metaphor like all the world's a stage, there could be a whole bunch of different ways to interpret this metaphor. So for instance, we have certain roles in the world, there's situations and expectations, it's dramatic and emotional, like what happens on stage. Now, other metaphors can be a lot less open-ended. So with a metaphor like a zebra is a piano, there's almost only one way to interpret that, which is that a zebra is black and white like the keys of a piano. So there's not many other ways you can really go with that. There's sort of one dominant interpretation. So a metaphor like all the world's a stage would be considered to be high in interpretive diversity, whereas a metaphor like a zebra is a piano would be considered low in interpretive diversity. And interpretive diversity is potentially an important factor in metaphor, especially for the appreciation of metaphor and enjoyment of metaphor. So when a metaphor elicits this richness of interpretations and is open-ended with a lot of different potential ways to interpret it, it can make the metaphor more enjoyable and more poetically appreciated. So interpretive diversity is influenced by two factors. One is the number of features, so more features is higher interpretive diversity, but also the distribution of the listed features. So as the features have a more uniform distribution, that also leads to higher interpretive diversity. So what I mean by that, let's say we have a metaphor that elicits 3 features, but the first feature is listed by 11 participants, whereas the other 2 features are listed by only 2 participants. So in this metaphor, since there's one feature that's dominating over the rest, this is considered to actually be lower in interpretive diversity compared to a metaphor that still elicits the same number of features, but each of those features are equally as likely to be listed. So the more uniform the distribution of the listed features, the higher the interpretive diversity. Okay, so what we asked in this study was, could we actually use vector space modeling to predict interpretive diversity? So just a brief overview of vector space modeling. The basic technique is to represent words as vectors, where the values in the vectors are based on word occurrences in a large text corpora. So the assumption is that words that co-occur together or occur in similar contexts are semantically similar. Once the words are represented as vectors, you can then calculate the similarity between 2 words by calculating the cosine of the 2 word vectors. And the particular model we used in this study was the global vectors model, or the GLOVE model for short. And the variable we looked at was semantic neighborhood density. So this is a measure of how many closely associated words there are to a target word in the semantic space. So a word that has many near neighbors or closely related words, closely semantically related words. Words that have many near neighbors are considered to be in a high density space, and words with more sparse neighbors are thought to be in a low density space. So you can calculate semantic neighborhood density. How we did it in this study was we calculated the average cosine similarity between the target word and its 500 nearest neighbors. So these would be the 500 neighbors, 500 words in the model that had the highest cosine similarity to the target word. We'd take the average of these 500 cosine values, and that would be our measure for semantic neighborhood density. So the basic task was we had participants list 3 features, and we had them list features for the metaphors, but also the individual topic and vehicle words in the metaphors. The instructions for the metaphors were to list 3 characteristics of the topic being described by the vehicle. So you can kind of think of the metaphor features as topic features, but ones that are being highlighted or made salient by the vehicle. And for stimuli, we used 88 A is B metaphors from the non-literary metaphor category from Katz and colleagues' 1988 norms. So these norms have been used extensively in psychology, in psycholinguistics research. And we also used, of course, the 146 unique topic and vehicle words within those 88 metaphors. Okay, so when you look at the feature data, you can have a lot of responses that are all tapping into the same basic feature. So for example, exciting, excited, is very exciting, has excitement. These are all really tapping into sort of an excite feature. So we developed a program that goes through the responses. It removes any sort of variations in punctuation or different marks, such as the dash before the feature. It removes all the stop words that aren't really adding semantic content to the response. And then it also stems all the words, so removes all the suffixes to get to the root word. And once these levels of processing are done, then the program can count these all as the same feature. So in this case, excite listed by 4 different participants. So this is an example of what the output looks like after we use our program to process the features for a certain metaphor. So basically you get a list of features here and then the number of participants that listed each one of these features. And then you can calculate the interpretive diversity score based on these numbers here. Okay, so first I'll go over the data from the topic and vehicle words when they're presented alone. So with the topic words, you get a significant positive correlation between interpretive diversity and semantic neighborhood density. So as the concept comes from a more dense semantic space, you get a higher diversity of features. Now, interestingly, for vehicles, there's no significant correlation, which is a little surprising because these are single words as well. So we kind of expected them to behave the same way. So this suggests there's some type of fundamental difference between topics and vehicles. Topics do tend to be more abstract words, so potentially that's why they interact more with semantic density. So we weren't really expecting this, but it is kind of interesting. Now, with metaphors, you actually get a correlation in the opposite direction. As the topic term in the metaphor comes from a more dense semantic space, you actually get a lower diversity of lower interpretive diversity for the metaphor. So opposite to what happens with single words. Now, with the vehicle term, there's no significant correlation here. So kind of similar to what you saw with the vehicle word data. So the semantic density of the vehicle term doesn't have any association with the interpretive diversity for the metaphor. So one additional analysis we did was to actually look at the change in interpretive diversity. So if you recall from the instructions, you can sort of think of the metaphor features as topic features, but ones that are being made salient by the vehicle. So what we did for this analysis was we looked at the difference in interpretive diversity between the topic when it was presented alone versus when the topic was embedded in a metaphor. So to calculate this, we just took the interpretive diversity for the overall metaphor and subtracted the interpretive diversity for the topic term. And that gave us our measure of change in interpretive diversity. And what we found here was an even stronger negative correlation. So as the topic term was from a more dense semantic space, we actually got more of a decrease in interpretive diversity when the topic was framed in a metaphor. And we did a median split on the SND of the topics. So we split them into high-SND topics and low-SND topics. And what we found was that for high-SND topics, there was a decrease in diversity when the topic was framed in a metaphor. But for low-SND topics, there was an increase in diversity. So this is interesting, kind of suggests that metaphor actually has an opposite effect on high-density topics versus low-density topics. Okay, so these data suggest that interpretive diversity varies as a function of the semantic space of the topic. So this suggests that the topic plays a critical role in selecting which features of the vehicle and also how many of those features are attributed to the topic. So this is consistent with Glucksberg's categorization model of metaphor processing. And the data on the change in interpretive diversity, this suggests that the function of metaphor might differ based on the semantic richness of the topic. So if you kind of take semantic density to be a measure of overall semantic richness, so words from dense semantic neighborhoods would be considered to have richer semantic representations. The idea would be that when the topic has a rich semantic representation, the metaphors actually help to constrain the meaning, focusing on just a few relevant characteristics that you're trying to highlight about the topic. Now, conversely, when the topic has a semantically poorer representation, the metaphor might help to highlight new features or less salient features, thus increasing the interpretive diversity of the topic. Okay, so that's everything I had for today, and I'll be happy to take any questions you might have.